Okay, we're going to start our unit on quadratic equations. And in the past, you've learned about equations of lines that were linear, like y equals mx plus b. Well, quadratics are going to be a different form. We'll talk about that. It's something that contains an x squared term. And instead of a straight line, we'll see that it curves. And the shape of that form, we'll use the term parabola. Okay, let's start by looking at what the standard quadratic form is. Okay, the standard quadratic form is y equals ax squared plus bx plus c, where a and b are coefficients in front of x squared and x, and c is just a constant or a number. Now notice, numbers are integers or fractions, and b or c might be equal to 0, but a cannot be equal to 0, because if a was 0, your x squared term would turn to 0, and you would not have a quadratic function. So let's see if we can figure out, by looking at quadratic functions, how to find a, b, and c. In the first one, a is equal to 2, the coefficient in front of x squared, b is equal to 6, and c is your constant, which is -8. In the second one, when they just have x squared, that's the same as 1x squared, so our a is actually equal to 1, b is equal to -2, and c is equal to 3. Our next quadratic function, which is a little bit different, a is again 1, but b, notice there's no x term, and the only way the x term would not be there is if it was 0x, which would be equal to 0, so b is equal to 0, and our c is equal to -7. Okay, in future sections, you're going to have to be able to learn how to find a, b, and c, so this was a good starting point. Now we'll actually learn how to get into graphing. Now you've made tables before when you did linear graphs, and we're going to set up the table the same way. And I'll choose some values to put in for x. I'll put in 0, 1, 2, -1, -2, and I'm also going to put in a couple fractions so you see how the graph behaves when it's near the origin. I'm going to put in 1/2 and -1/2. Okay, plugging these in, 0 squared is just 0. So when x is 0, y is 0. We put in 1, 1 squared is 1. So when x is 1, y is 1. If we put in 2, well, 2 squared is 4. So 2, 4 is another point. If we put in -1, -1 squared is +1. Negative times negative is positive. So when x is -1, y is +1. If we put in -2, -2 squared is +4. And 1/2. A lot of people get this confused. 1/2 squared means 1/2 times 1/2, which is 1/4. And if we put in -1/2, a negative squared is a positive, and again 1/2 times 1/2 is 1/4. Now when you set up your scale, just for this first graph, I want you to use every 2 blocks as 1. This will help us better see what happens to the graph when it's close to the origin. So again, just for this graph, make every two blocks equal to 1. Okay, once you have your graph set up, we're ready to plot the points. Well, 0, 0, 1, 1, 2, 4, then we have negative 1, 1, negative 2, 4, and let's look at these fractions here. 1/2, 1/4. Let's see, 1/2 would be there, 1/4 would approximately be there for y. And negative 1/2, 1/4. Now we could use smaller fractions too, but the point to be made here is it forms a smooth curve or bowl at the bottom, then rises steeply. So this is the basic shape of a quadratic function, one that has an x squared. And we have a name for it. The shape is called a parabola. The vertex is the point at the top or bottom of the parabola. In this case, it'll be at the bottom. If we had an inverted or upside down parabola, the vertex would be at the top, and we'll encounter examples of that later. So the vertex for this problem is the point 0, 0. All right, let's try another one. Let's graph y equals 2x squared. And this one, we'll just go one block on our scale equals 1. We won't extend the scale. We'll pick out the same values, 0, 1, 2, negative 1, negative 2 to plug in. 2 times 0 squared is 0. So when x is 0, y is 0. If you put in 1, remember to square the 1 first. 1 squared is 1 times 2 is 2. Put in 2. 2 squared is 4 times 2 is 8. If you put in negative 1, remember when you square a negative, it becomes positive. Negative 1 squared is 1 times 2 is 2. And we'll put in negative 2. Negative 2 squared is positive 4 times 2 is 8. Okay, let's go ahead and plot these points now. 0, 0, 1, 2, 2, 8, negative 1, 2, and negative 2, 8. Now, if we did fractions, you would see that, again, we get a curve at the bottom. Not perfectly drawn, but again, it is our shape of a parabola. The 2, our other parabola, y equals x squared, was approximately out here. The 2 made the parabola narrower, steeper, if you would. All right, let's try another one. Let's see what happens when we have a negative in front of the x squared term. Again, we'll use the same values, 0, 1, 2, -1, -2. And just be careful, whenever you substitute a value in, you should put it in parentheses. 0 squared is 0, and -0 is the same as just 0. If you put in 1, you have to square the 1 first, which is +1, then apply the negative, which gives you -1. Again, just like order of operations, you must square the 2 first, which gives you +4, then apply the negative, which is -4. If you put in -1, you must square the -1 first, giving you +1, and then apply this negative, which gives you -1. -2 squared is +4, and then apply the negative, makes that -4. Okay, let's go over and draw in our x and y axes. And again, we'll just use a scale of 1 per block. Plot the point 0, 0, 1, -1, 2, -4, -1, -1, and -2, -4. So what we have now is our parabola is inverted or turned upside down. So whenever you have a negative in front of the x squared term, we're going to see this pattern develop where the parabola is, well, you could refer to it as upside down or inverted. So certain patterns start to develop. When you have a number greater than 1 in front of x squared, it begins to get narrower. When you have a negative, it will turn it upside down. There's a few problems. This isn't the assignment, but you'd start, if you went ahead and tried these problems, again, the assignment will be in the text, but you'd see some patterns developing here. Like the negative here, when you graph it, you should have an inverted graph, and the 2 would make it narrower. And you'll see other patterns develop when you have a constant going plus or minus. It's simply going to shift the parabola up or down. It'll move the vertex up or down, and you'll see that pattern develop. So there'll be problems in the assignment. If you want to try some of these first, I think you'll see some definite patterns develop that you'll start to recognize after a while. Okay, that's it.